Okay, good morning. I'm George Sage, and today we're going to talk about balancing your flywheel at home or at any convenient location. Okay, one of the things we had in mind, one way to do it is to use a wheel balancer. This is a stand with a point. There's a very sharp point on the tip here, which fits up inside, centers this. So we drop this on. Then this is spring loaded, and then the cone on here, if you can see this cone, centers whatever you put on here. Normally you would put a wheel on here, and this would go down and it would center over the cone. So we want to do a flywheel. So here we have a flywheel, and we want to be able to balance not only the flywheel, but the flywheel with the pressure plate on it. Turns out, well, first of all, it turns out these balancers are available on the internet. There's several manufacturers that make them, and they run anywhere from probably around $60 to they were a little over $100. So the first thing you'd want to do with your flywheel, and if you can see this one, I don't know if we can see that, but this ring gear is beat up pretty bad. When your starter comes in, when the gear comes in, it comes in from this side on the flywheel. So you'd want to replace the ring gear with the tapered part of the ring gear to the inside. Then as far as the flywheel itself, when we balance it, we're going to put it on here, and it's a bubble. There's a bubble balancer in the center. So we're going to put it on, put weights on, find out where the weights go, and then if you can see here, to balance it, we just drill a hole and remove metal from the heavy side. The other thing that you're going to want to do, probably before you balance it, you're going to want to surface this clutch area. This is where the clutch fits, where your clutch disc fits right in. Here's your transmission shaft and your clutch disc. So we're going to want to surface this area. Now keep in mind that when you're surfacing this area, you also have to surface this area where the pressure plate bolts on. The reason you want to do that is that the dimension from this surface to the surface of the flywheel has to be, and it's 1.123 inches. So you want to maintain that difference. So whatever you take off by surfacing the disc area, you also want to take that same amount off where the pressure plate bolts on, so that you maintain that difference, 1.123. So once you've got that done, the reason you do that before you balance it, because if you took too much off, it would make a difference. So now once you get that done, and this weighs like 64 pounds, and I'm 91 years old, so if I can do it, you can do it. So now we're going to slip this over. And so now we're going to, now remember that we have that cone, so the centering hole, right, you won't have a pilot bearing in here when you do this. you'll have to have the pilot bearing out. But once you slip that down over here, this has to sit down on the cone so that it comes in level. And you can see it's not bad. This is not bad at all. So it looks like it's high right here. What you're looking at is the bubble, and you want to get the bubble in exactly the center. So we're going to put weights on here. We just take, doesn't matter, just anything, use anything for weights. Okay, so now that's about, so now we've got, by adding some weights here, we're going to have to take weight off of over here. You could see, maybe you can, right here where it's been balanced before, and they just drill and remove material. So we drill into the beefy part of the flywheel to remove material, and to determine how much to remove, we put some weights on, and you can use anything for weights. Incidentally, the bolts that fasten this on should be grade 8 bolts. You want grade 8 bolts, and preferably with lock washers, because you don't want this to come off. So what we have here is a scale, and we're going to turn it on and set it for ounces. Then we will take these and we have 1.4 ounces. So we need to remove 1.4 ounces from the area exactly opposite, because we were on the light side, so we put more weight on this side, so that means that to balance we have to take off weight just the opposite side. The depth in inches is equal to the weight in ounces divided by 0.912. And you could almost say that the depth in inches is equal to the weight in ounces. Now, you have to remember that the drill has a tapered tip, so even though you drill in, say, 1/4 inch, do you measure the 1/4 inch? If you measure it all the way to the tip, you're not getting the full volume. So you have to compensate a little bit. We could go through and calculate that, but depends on the tip of the drill you use. But the idea is, this gives you a real close idea of how deep to drill in order to compensate for that much weight that you find out. Then you may end up having to drill a little bit more. And as a matter of fact, what you might do is drill part of it, because once you drill, you may find out, oh, I should have moved that a little bit. You know, maybe you're off, just not quite square with where the weights were, and so you can then do it more than once. In fact, you'll notice on here a lot of flywheels are drilled in more than one place. So they drill it, test it until they get it right. So you may not get it right, exactly right the first time. Now that's balancing the flywheel. But that's not the whole story, because we still have to we're going to put this pressure plate on, and the pressure plate may or may not be balanced. I've been told by the suppliers that it is balanced and adjusted. However, I guess I don't really believe them because I've purchased them and then measured them, and they're not necessarily adjusted or balanced. So what we're going to do, we're going to set this on there, line up the hole so it balances at a particular hole position. And it fits down inside of a groove here, so you want to make sure you get it centered in there. So it's not bad. I'm going to turn my light on so I can see down in there. I'm also going to put on some glasses and whatever else I can do to help. But when I look in here, my bubble is right here. So we're going to put our weights on this side. And so this is a little tricky, so you're going to have to work with it and go through and find just exactly where that balances out. Anyway, so that's the technique. Now you get it, so you put your weights on, determine what it takes to balance it. Then, once you have determined that, you've determined what it is in this position, so be sure and mark. What I like to do is take a punch and punch a punch mark on one side and a punch mark on the pressure plate, so you can line those up. If you mark them with a chalk or something, then you sit around for a while, and that eventually that chalk will get wiped off just from handling. So it's best if you punch, just do a punch mark and make it big enough so you can see it, so that when you put this back together, you can get it back in the balanced position. Okay, now that you have it all balanced, you've got it balanced together. Now with this setup, we weren't able to balance it with the clutch disc in place. So we're going to have to assume that the clutch disc is balanced independently. So now what we'll do, we will put the disc in, we will put the pressure plate on, tighten it all down, and those are grade 8 bolts. So we're going to tighten it all down. Once we do that, these fingers, and you can see there are different heights, we need to adjust those fingers by adjusting these nuts here. We need to adjust so those fingers are all exactly the same height. We want them to be all the same, so when your throwout bearing comes in, we want that throwout bearing to hit all 6 of these levers at precisely the same place. So then what we want to consider is that the optimum, most efficient angle is 90 degrees. So when you have a lever and you want to be pushing at 90 degrees, that's your most efficient. Use the same thing on your mechanical brakes, on any lever system. You want that 90 degrees. Well, when you put this together, your clutch, when your pedal moves down, you have 1 inch of free play, so your pedal moves 6 inches to the floor. That 6 inches to the floor amounts to 5/8 or 0.625 inches of movement of that throwout bearing against these levers. And when they push these levers in, that opens up your clutch pressure plate away from the flywheel so that the clutch disc can slip then. So since we want to move 0.6 of an inch through, we actually want to start 0.3 of an inch above level and go to 0.3 of an inch below level. So we want to calculate then the exact position of these, and what we're going to do, we're going to calculate it from this surface so we can put our arm across this surface. And when we do that, the number we come up with, and I apologize to Les Andrews because he has suggested either 5/8 of an inch from this surface in his book, and then later he suggests 3/4 of an inch from this surface. Neither one of those is the most optimum. The number that you want, that is the most efficient number, is, and it's actually 0.503 or 1/2 inch down. So we're going to take this arm, we're going to put magnets on it to make it convenient. We're going to put this bolt on so that the head of this bolt is 1/2 inch below the surface of this magnet. Now it's hands-free. You can just lay this in there. And what I like to do is set that at 1/2 inch and then take say a 20 thousandths, or 20 thousandths is convenient, feeler gauge, and lay it in between the head and that, and then you adjust this nut. Now, one of the considerations is that the bolt that you have to hold that bolt from turning, and that bolt is slotted. So the first thing you have to do, the nut has been peened over into that slot. So the first thing you're going to have to do is clean that slot out. So you take a hacksaw and just a couple of wipes through there, take that where it's locked in, and adjust that nut. But the screwdriver that you use to hold that bolt in that slot, a screwdriver is tapered. If you try to use the screwdriver that's tapered, this slot is deep enough that you're going to take that bolt and you're going to open the bolt up. So you don't want to do that. You don't want to use a screwdriver that is tapered. You want to take a screwdriver and file it so that you have a nice straight edge on it. Then you hold that screwdriver in that slot, adjust that nut until you have just the right height. The difference between a 1/2 inch setting, at a 1/2 inch setting, your clutch, the pressure on your clutch lever will be 35 pounds of pressure to put your clutch to the floor. If you set it at 5/8 of an inch, see if I got all these numbers right. If you set it at 5/8 of an inch, you can be at almost 40 pounds of pressure. And if you set it at 3/4, it's more than 40 pounds pressure on the pedals. So the most efficient place to set it is so that these are 1/2 inch. And I do have concurrence from Les Andrews that that's okay. But there are probably several other ways that you could balance this. You can hang it, say, from a cherry picker, and you could hang it, and then you'd have to be able to center it on your tool. You have to make some kind of a holder that would hold that like a plumb bob, and then you could put the weights on it, then use a level to level it. And there's probably other ways that it can be done, but this is a pretty straightforward way to do it. Now let's talk about the pressure plate. This pressure plate, there are 12 springs in here. Each one of these holes there's a spring. Each spring is compressed, and it has a compression factor of 100 pounds. So you got 1,200 pounds. What it ends up being then is when you bolt this onto the flywheel and you put compression on those springs, the surface that is pressing on the disc is 1,200 pounds. So you have 1,200 pounds of pressure on both sides of that disc to hold that disc. That's what keeps it from slipping. So you see, if this dimension here, 1.123, is too great, you're not going to have the full compression against that disc. So it's important that you have all these dimensions correctly. Now, if when you've adjusted these, the nut is on the stud that is slotted, and the nut has a shoulder on it, so that once you get it adjusted, you take a punch and you just punch that shoulder into the slot. That locks it so that it can't change adjustment. Now there are some nuts that do, some military nuts. In fact, they would be, and I think these are 5/16 24M, like military. And they are self-locking. So that's another way to go about it. But once you get them all adjusted so that you're the 1/2 inch down from this surface, then they need to be locked in place. Now these bolts, and there are 6 of them, they start from the head of the bolt is in the plate. So they're specially made bolts. There are available some bolts that can be used in place of these, but if you ever want to take one of those out, be sure you only take out one at a time. So if you had to remove this and replace it, you want to only do one. It's very difficult to get this back together. In fact, I wouldn't recommend it. Anybody takes one apart unless you have all the tools to do it. You have to put it all together. You have to get all 12 springs in, and you have to put pressure down. It's not a very good idea to try to take it apart, and really there's no reason to. The springs are all basically all set at the 100 pounds of requirement. So if you take it apart and want to put one back together, you'd have to measure each spring so that the spring coefficient is all the same on every one of them, and positioning those. They're held by this hole is concaved in, pressed in, so that holds the top of the spring, and there's a little foot on the other side that holds the bottom of the spring, and there's 12 of them. So they all have to be lined up at exactly the same, and then the nuts put on and held it into place. So what happens is occasionally, if somebody uses a tapered screwdriver, they can break off the tip of that bolt. You can replace it, but just replace one at a time. Okay, here we have the back side, or the side that goes next to the engine. The crankshaft would bolt in here. And if you can see, this one weighs 64 pounds. It's a standard flywheel. This one, you can see we have cut away material in here, right in here, and we've taken off, and I believe it's around 20 pounds that we took off. So you can make it into you can lighten the flywheel, but you can also buy the flywheel lightened from some of the suppliers. So there's two things. We lighten the flywheel, gives you a little more acceleration, whether or not you can tell it, but when you want to spin up 64 pounds, takes a little more energy to get it going than it does to do a 40-pounder. So it just means that you have a little more snap. Doesn't change anything else, it just gives you that more snap. Now, in addition to that, I'm going to show you what the other thing you can do. And in this case, remember I said that this had to be exactly 1.123 to get the right pressure on here with the pressure plate. What we've done is we've cut this whole ridge off. So now the flywheel is just flat all the way around. Then we relocated the mounting holes, and we can install a V8 clutch. And this is the pressure plate from the V8. Basically, does the same thing, only has 3 fingers instead of 6, and mounts a little differently, but this will fit right in to a Model A. So you can use the same thing, same throwout bearing, but you can lighten the flywheel by taking off of the inside, and also you can lighten it even more by taking off the rib on this piece here. Not a big deal, but some people do it. Not sure that the V8 clutch is all that much better, but some people think it is. So anyway, that's a lightened flywheel, roughly 40 pounds to 65 pounds. Okay, well, thanks for watching, and check out some of the other videos. Hope this helps you get your Model A on the road.